Venn diagram regions. So in this video, we're going to talk about specifically about a Venn diagram with two interlocking circles, which are the most popular Venn diagram. And one thing I want you to focus on, or I want you to notice at first, is that this Venn diagram only has 4 different partitions. So we have the middle partition, which is probably the most famous, the intersection of A and B, right? We have our set A here and our set B here, and where they intersect is right there, A intersection B. We have this other region right here on the side. There we go. That's A and not, because if you look at it, right, it's all of A, but we take out the part that it shares with B. So the way to symbolize that is A and not B. It's the intersection of A with what's not in B. Like that, those two together get you this part right here. So it's A without any B without touching any B. So it's only like this half crescent there. And then we have another portion here. This guy. Not my best drawing there. Let me go back. That was a little better before I did all that. Here we go. Right, and then likewise, this is B that doesn't have any A in it. So this is B and not A. So that's my portion, region 3. Pull it off the edge there. And then we have one more region. Oh, sorry, I wasn't happy with my coloring. That's the whole outside. That's the 4th region. So the whole outside. Right, it looks like the biggest region. It doesn't have to be. Most of the time it's actually not. But it's just the way it's symbolized. There we go. Right, so that's the stuff that's not in A or in B. Another way to write that, it's the intersection of not A and not B. So if you look at not A is everything like that's not in A. Not B is everything that's not in B. Where they overlap would be the whole outside. So those are the 4 regions of a Venn diagram like this. And I want you to notice that if you add your universe, is just the sum of those 4 regions. If you add up A intersection not B, right? If you add this portion, if you add this portion to this portion to that portion and that portion, you get the whole universe. So that's what the whole universe of a Venn diagram is made up of. It's only those 4 portions. If you have find all the values of all these portions, you add them up, you get the universe. Or likewise, if you have the universe and you're missing a portion, just subtract. That's what we're going to focus on today. Because a lot of times with Venn diagrams, we actually care about the number of elements in each little set we have here. So for example here, right, I have 7, 4, 6, and 3. 3 is the whole outside. Again, I know the whole outside looks big, but it's just 3 elements. That's all it symbolizes. The portion here that's only in B, but not has anything to do with A, is 6. A and B both share 4, and then the portion right here that's only in A and not in B is 7. So if I was trying to figure out what the universe of this set was, I just add up all 4 of these regions. 7 plus 4 plus 6 plus 3, and I get 10 plus 10 is 20. So the universe here is 20. Also, just as important, you might want to know how many things are just in A by itself, like the set A. That would be this whole circle here, right? A is not the 7. 7 specifically what's in A but not in B. If I wanted all of A, it would be that whole circle, which would be 11. And likewise, if I wanted all of B, it would be 4 plus 6, which is 10. So you can get all this information from a Venn diagram. Okay, let's do an example. Use a Venn diagram to find the number of elements in P. So look, here's my set P. Remember, set P should be the whole circle here. So that's going to be 10. It's the whole circle. Next one, not Q. So let me actually let me highlight Q. Right, there's Q. I'm going to highlight it. I want not Q, so that's everything that's not highlighted. So that'll be 7 plus the 4 on the outside. Right, so it'll be this portion of 7 of P that's not in Q, that doesn't share anything in Q. And it'll be the outside of neither. So my answer here will be 7 plus 4. So 11. That's how many things are not in Q. Next one. P union Q. Now remember, the union works as long as you touch one, you're both. Like you're in if you, it's the union of P and Q. So it's both of them put together. Right? So it's all of that. That's my P union Q. So it's combination of P and Q. So 7 plus 3 plus 11. Which would be 21. Next one, P but not Q. So this is where it gets a little tough, right? So you want P, but you don't want any part of Q. So that should just be the 7 right here. This is a P, not Q, right? I want P, but I want any part of Q. So you don't do the intersection part, so it's just that part. Q, not P. Likewise, it's on the other side. I want Q, but I want any part of P. Oops. So that'll be this portion here. Right, so that's Q, but has no part of P in it, so it's just 11. And then neither P nor Q, so I don't want any part of P or Q. So first I could look at it as, okay, here's P and here's Q, but I don't want any part of any of those two. So it's just the outside. So it's just the 4. That. By the way, I didn't ask here, but if I wanted the universe, right? If I want how many things are in total in the universe, I just add all these up. So it'd be 7 plus 3 plus 7 plus 14. That's 25. My universe was 25. Okay, let's move on. The next one, ooh, they don't give us a Venn diagram. I'm going to draw one myself, though. The number in the universe is 30. So that's what that says. So remember, the n there just means the number of items in the universe is 30. So let me draw a Venn diagram. As you can see, I cannot draw rectangles. I think my problem was I did them all. I did like separate lines. Anyway, there's my rectangle. My universe is 30. You have an A, and you have a B. There we go, that's fine. The number in A is 14. Now, watch out. The most common mistake is people put 14 on this portion right here. That's not A. A is the whole circle. So I'm just going to put like parentheses 14 near A. So I know the whole circle is 14, not just this portion. The number in B is 17. So same idea. Right, the whole circle is 17, not just this side right there. Here's the key to it all. The intersection is 6. So that opens up the whole thing for me. So the intersection is 6. So I know this is 6. Right, why is that so important? Now I can figure out what these two portions are, right? If this is 6, the whole of B is 17, so I can just do 17 minus 6, and I get 11. On this side, same idea. All of A is 14. 14 minus 6 would give me 8. And then look at question A. What is N? What's the number of N union B? A union. What did I say? N. A union B. So I want to figure out the number in A union B. Remember, A union B is just A and B together, all together. So I'm going to add all those up. So it'd be 8 plus 6 plus 11. So 17 plus 8 is 25. So that's what's in A union B. B, how many are in A but not, how many are in A but not B? So remember, you gotta know what that is. So let me erase my highlighter. That was too much. I'm gonna over highlight my highlight. Okay, so we gotta figure out how, I want the number in A but not B. So where is A not B? So here's A, but I don't want any part of B. So it should only be this little crescent moon. So it should be 8. I'm going to write it like this. A and not B. That is 8. By the way, a couple other things I can figure out. I know the universe is 30. How about if I asked you, C, what's in neither A or B? What's on like the outside here? What's in this? Right? I know the universe is 30, and I know these 3 circles is 25. So you just subtract. 30 minus 25 would be 5. Right? Because this whole union plus the outside gets me 30. Okay, so there's that one. Next one. Use the Venn diagram to find the number in B. So notice how these are just letters, just variables. We're just going to use variables to answer it. So in B, B is all of this. So it's just going to be B plus C. Not A. So again, figure out what A is. A is all of this. So I want not A. So that'd be C and D. The number in A intersection B, that's easy. I don't need to highlight. That's just B, lowercase b. The number in A union B, remember A union B is when you put them all together, both circles together. So it'll be A, B plus C, A plus B plus C. The next one's interesting, right? So it's A intersection B, but then not. So let me erase this so we can talk about it. So a good way to do this is like, what is A intersection B? That's this thing, right? They want not that. They want everything else. So I'm basically going to take this not include the B. So it's everything else. It's A, it's C, and it's D. Right? Because the only thing I don't want is the intersection. Similar idea for the next one. A union B, but I don't want that. So what's A union B? The two circles. But I don't want that. So what's the opposite? What's not that? Well, it's the outside. D. By the way, we talked about what this outside is before, right? So now we have two ways to write it. We could write the outside here as A intersection, A prime intersection B prime, or A union B prime. They're equivalent. So two ways to write the outside there. Anyway, let's move on. I think the last example for this problem. Given the universe is 50, S is 30, R is 25, and R union S is 48. Find the intersection. Okay. So we have R, we have S, we have our universe, which is 50. So our universe is 50, R is 25, and S is 30. And I want to find the intersection. To do this problem, I can introduce you to a formula. And that is this formula from the formula sheet, which is the number in A union B is equal to the number in A plus the number in B minus the number in the intersection of A and B. So it's saying if you have the union here, it's just you add the one circle plus the other circle and subtract off what they have in common. The reason this works is when you add one circle and then you add the other circle, you're double counting the middle. So you have to subtract off one of the middle, and then you get an equal equation. So that's an equation. It's in your formula sheet. We're going to use it a lot, and that's how we have to go across this problem. So I know I'm looking for the intersection. Now again, we have R and S, so we're just going to change everything. Let's say R and S, R and S, R and S. So I'm going to have the number in R and S equals the number in R plus the number in S minus the intersection of R and S. Now look what we have. We have R is 25. S is 30. The intersection I don't know, so I'm looking for it. I'll put an X there. And then I do have the union, which is 48. And I wrote it wrong in my formula right here. That should have been R union S. So this is 48. So using this equation, we can solve it. 48 equals 55 minus X. So plus X minus 48. You get X equals 7. So that's how much it is in the intersection. 7. And once you get the intersection, the rest of the problem, the rest of the Venn diagram you can fill out. So this is 7 now, right? If I know that's 7, I should be able to figure out what this side is. It's 30 minus 7, which is 23. I need to figure out what this side is. 25 minus 7 is 18. I can even find out the outside, right? Because this is a universe minus these things. So it's the universe minus 30. 7 plus 23 is 30. So 20 minus 18, it's 2. Right? Once you get the intersection, you can find the rest of it. So again, the intersection was 7. This whole circle was 30. So 30 minus 7 got me this 23. Same idea here. The whole circle is 25. Subtract the intersection, 18. Now how do you get the neither? What's this the universe minus the circles? So 50 minus 18 minus 7 minus 23, which is 48. So 50 minus 48 is 2. Now let's go to the question they're asking. Find the number in S but not in R. So again, we gotta know what that is. S but not R. So I want S but I don't want any part of R. That's just right there. And that is 23. And there we go.